For this video, we're going to show how to solve the acceleration equations for problem 4 on the take-home on the test, sample test. We were told that the input velocity was constant, and so we know that R4 double dot is equal to 0. Now, just because R4 double dot is equal to 0, that does not mean that R3 double dot is equal to 0 or that alpha 2 is equal to 0, and we'll see why in just a moment. Okay. But what we can do then, so what we have is we'll have R2 alpha 2 I e to the I theta 2 minus R2 omega 2 squared e to the I theta 2 plus R3 double dot e to the I theta 3 equals 0. And so we can multiply through by e to the minus I theta 3, and that will give us R2 alpha 2 I e to the I theta 2 minus theta 3 minus R2 omega 2 squared e to the I theta 2 minus theta 3 and plus R3 double dot, and that'll be equal to 0. We can take the imaginary part, and that will give us, from this first term, we'll have R2 alpha 2 cosine theta 2 minus theta 3, and then minus R2 omega 2 squared sine theta 2 minus theta 3 plus 0, and that's going to be equal to 0. So when we solve for alpha 2, we'll find that alpha 2 equals R2 omega 2 squared sine theta 2 minus theta 3 divided by R2 cosine theta 2 minus theta 3. And so the R2's cancel out, and so we find that that's equal to omega 2 squared, and that's just going to be tangent theta 2 minus theta 3. And so you can see what's going on is the angular acceleration of length 2 is proportional to the angular velocity squared, and then you got a tangent factor going on as well. All right. And so the fact that we've got omega squared in the equation, that's why setting the alpha equal to 0 doesn't make the velocity, all the accelerations go to 0. All right, so we can then find what R3 double dot is equal to. We go back to our original equation, back to this guy, and we will multiply that one by e to the minus I theta 2, and that will give us R2 alpha 2 I minus R2 omega 2 squared plus R3 double dot e to the I theta 3 minus theta 2, and that's going to be equal to 0. And so we want to get rid of that term, so we're going to take the real part, and that will give us minus R2 omega 2 squared plus R3 cosine theta 3 minus theta 2 equals 0, and so we'll have R3 double dot is equal to R2 omega 2 squared divided by cosine theta 3 minus theta 2. And that will be our equation for R3 double dot.